It's
All right. Hello, everyone. Good morning. Very excited to be here, and very excited to present my learnings over the past few weeks regarding identity and also how that applies to agentic AI. My name is Siddharth, and today I'll be presenting autonomy needs authority, identity, and access control for AI agents. Now, before I start the presentation, I just want to have a good idea about my audience. So I'd like to ask you, how many of you are, just exploring agentic AI or even AI ML for that say, by a show of hands, please. So I'm guessing you're all pretty new to agentic AI and also AI ML in general. And how many of you are still exploring cybersecurity or are kind of beginners, or intermediates in cybersecurity? I consider myself an intermediate as well in cybersecurity. So, all right, cool, great. So in the slide you see a diagram, right? This is like a parent, child, and then grandchildren. So this gives a good idea about my talk as well and the risks that come from an agent spawning a sub-agent and its children, multiple grandchildren, etc. So I'd like to introduce myself first. I'm Siddharth. I work here at Flipkart. I have about 4 years of experience. I have been into security since my childhood. I've been very passionate about security since, and I love building and breaking things. And I started my journey in cybersecurity, via penetration testing, etc. But always a technology enthusiast. So I did my master's and I pursued data science and artificial intelligence in that, where I, pursued my research in adversarial machine learning. For those who are wondering what adversarial machine learning is, it has something to do with fooling a model. All right. So let's say, you have these Tesla cars trying to predict or recognize a traffic sign and predict what's written on it, right? And then as an attacker, what I might do is I might place a small patch on that particular traffic sign, and that would fool the model that is capturing that particular image. And if it's a stop sign and there's like a, the road ends over there and says stop, as an attacker I would place like 100 kilometer per hour sticker that would not an actual 100 kilometer per hour sticker, but just a small adversarial patch that would make the model think it's a 100 kilometer per hour sign. So that's destructive, right? So that's with the malicious intent. So there are more such use cases. I've also worked on how to mitigate those using adversarial training as well. So if you'd like to chat about that post, this talk, I'd be happy to do that. All right, so let's start with this scenario where, before we get into the scenario, I'd like to just explain what AI agents are. For those who are very new to agentic AI, AI agents are basically tools or security programs that have a certain machine learning model, which is the brain of the entire software program. Then they have access to certain tools. Those might be APIs, etc. And they have a certain amount of memory that keep a control of context. Now, why are AI agents so important? Because one, they can act autonomously and intelligently. They're not your general automation scripts, right? Where you hard code everything. Here instead, you give them a task, they will plan and orchestrate how to do that particular task and then act on it, right? So they are working towards accomplishing a goal that you've set for them. And we'll get to what intent is in a few minutes, because all these AI agents work on what kind of prompt you give them and what task you give them, and they create their own plan, right? They orchestrate their own plan and then they act on it to achieve that particular goal. So in this particular scenario where, let's say I'm Siddharth, I'm a Taylor Swift fan, and I'd like to assign my AI agent a task saying, hey, buy me 2 concert tickets, and my budget is somewhere over $1,000, nothing more than that. Please book me a Taylor Swift concert that's happening in Mumbai, and plan everything for me. And the agent actually goes ahead and books your ticket. However, right, here in this case, you're having to provide your personal details, your visa details, your credit card details, basically for it to perform the payment as well. So as soon as I say credit card, right, you're all already thinking about the risks that it possesses. So there are two things here where everything goes right and you're happy about your agent purchasing your ticket at the right price and at the right venue. But the nightmare scenario here is, what if your agent, instead of purchasing $1,000 ticket, it thinks, oh, I'm getting a VIP seat at $50,000, and it thinks that's a better value. So it goes ahead and it has your credit card details and it purchases your ticket at 50,000, which is way over your budget, right? Now, it might sound like this is a very simple task, but your agent has searched for the event, it has searched for the venue, it has searched for vendors that are providing the ticket, and then purchased the ticket, right? So there's a lot of planning, and then the action where it actually makes or hits the payment API, right? Or visits the payment gateway and makes the entire payment. Now, in this nightmare scenario, you as an upset customer, you go to customer support, you say, hey, look, I assigned my agent to do this $1,000 job, but instead it went on and bought a $50,000 ticket. I'm not happy about it. Please refund my money. I don't want to go to the concert. I just don't like your company. Just, he's very frustrated and he is demanding his, refund. Now, in that case, the customer support, they go back, they check their logs. Did Siddharth actually make that transaction or not? And, all they see is that, yes, Siddharth made that transaction. But who actually made the transaction over here? It's the agent that made the transaction. But when you see a log, right, if you are logging all the actions in a certain computer system, you see all the actions, who did what and how, right? And in this case, you see that Siddharth or sid@abc.com has actually executed the payment. There's no mention of agent. There's no mention of any AI system, nothing whatsoever, right? Because that was your personal shopping assistant, and it got the ticket for you. Now that creates a problem, right? Because who's accountable here? Is Sid accountable? What if your AI agent, actually even books your ticket at the right price, but books it at a different venue? Is it a user fault or fraud? Is it a platform error? What is it? Who is actually accountable if the log only shows that Sid made the payment, right? And there's no agent identity to actually have that in your log saying agent A made that particular payment call. So here's a critical question, right? If the agent created the intent, why does the audit log say Sid authorized the payment? Sid did not authorize the payment. Sid only said, hey, buy me the ticket at this price, my budget is this much, don't go beyond it. But the agent still goes ahead, buys an overpriced ticket, and there's no log of the agent actually performing the ticket. The only log that is there is that Sid authorized the payment. Remember this critical point. Now, let's get to the paradigm shift where, nowadays we're forwarding intent, and we've moved from the traditional apps where, let's say you as a user, you go to a web application, you add something to cart, you are okay with the price, you did your research, and finally you're at the checkout page and you do click a button of checkout, right? You as a user are aware, you're consenting to everything and you're pressing a button, and that goes to a certain API call, correct? That was the traditional way of doing things. Now, if you think about the present where your AI agent is doing the job for you, the AI agent, as I said, it plans, orchestrates, and then acts on your behalf, right? And it is creating its own intent. You have delegated it a task. However, For it to plan and act, it creates its own intent. It goes through the web, it compares prices, and then executes the transaction, right? And what is the problem here? The problem is that AI is non-deterministic. Humans are very deterministic in the way that you say, I need something, you go there, you check the price, you know you want it, you press submit, and that's it, right? AI agents, however, are different. For the same output, so for the same input, you might get different results, right? You might not always get the same result. So here, the AI is creating the intent, not the user. User only delegates a task, AI creates its own intent. So here you're not forwarding a request as such when you press a submit button, right? Where, let's say in a web application scenario where the user is clicking on a submit button, he is forwarding a request that is already coded, right? That is hard coded. You can't change that. However, in the present scenario where you're assigning a task to AI, you're forwarding an intent, right? So that is the problem over here. And that is a paradigm shift that I want to stress upon, that when agents create intent instead of forwarding it, delegation becomes abdication. Abdication is basically, you're delegating a task, but you're throwing away all your authority to your agent, right? You have no control over it. Alright, so let's discuss why exactly this happens. Why does traditional identity, or why do these traditional constructs break down in the agentic case, right? So in a general scenario where a human is doing all of this, human identities are generally permanent, right? For example, you get an ID card that stays for you forever, right? But in an application scenario, they're kind of long-lived. In an AI agent, or in any AI scenario, right, they're ephemeral. Ephemeral is basically a short-lived span where an agent can live for 30 seconds and then self-destruct, right? So that is the difference between human application and then AI agent. Then decision-making, human intentionally consents to performing an action which is already hard-coded. You press that, that's done, right? Applications are also deterministic. AI agents are autonomous. They make their own decisions and they make their own intent, right? The authentication method for traditional human or application are, SSO and client secrets, client ID. In an AI agent, we still use the traditional methods. We'll talk about how that works. Delegation, here the human consents to it, right? A human actually sits in front of a in front of a screen and presses allow. Right? You must have, been through all these authentication flows where you're allowing a third-party application that wants to access, let's say, your Google Calendar, right? You say allow. Right? You first put on your login credentials and then Google shows you, hey, this particular application is trying to access blah, 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 and you consent to it saying allow, right? In an AI agent, right? There is no such thing as consent yet, or the lines are kind of blurred. We'll see why, and that is the reason why traditional identity fails here. Now, the first thing that we need to realize is that we need to have an ID card for the agent. We can't just have ID cards for human, right? ID card is your identity, right? My name is Siddharth, that's my identity. Do we have identities for agents? My identity is being logged in some system as sid@abc.com. How is the agent being logged, right? If the agent does not have an identity, how will it ever be logged? Before I discuss any further about how authentication, authorization, access control, identity, all this happens, let me just explain a few terms so that this is very clear and we don't confuse between any of these. Identity is basically who you are. Authentication is prove it that you're Siddharth. Authorization is what can you do. Access control is should you do it now, right? And with agents, there are a few problems. One, do agents actually have a unique ID that we call agent identity? Not really right now. Authentication, it has a few flows, but there are drawbacks to that. We'll discuss that. Authorization, there are static scopes. Now, the problem with static scopes, I'll get to that as well, is that agents are very dynamic, right? When they're creating intents, they keep changing, right? It keeps changing on, the current research that they do. It keeps changing based on, a certain web page, etc., right? So they're not human given requests that are being forwarded, they're intents that are being dynamically generated. So static scopes won't work. For example, even though you've given the agent a 50,000 budget, it keeps overspending, right? At that point, if it wants to perform a different task, static scopes will not work. So, how do we actually build identity for agents, right? That is still ongoing research. Everybody is breaking their heads over how do we build identity, how do we, get authentication or authorization working for agents. And what people have figured out is that let's stick to our standards that are currently present. So, a lot of us must have heard of OAuth. We all must have used it in some way or the other in some flow. I gave you an example of, some application wanting to, access your Google Calendar, right? You put on your login credentials and you give consent. That's basically, more or less the OAuth flow. Now, an interesting thing here is that before all this happened, when people were building protocols for agents, people were building protocols for, AI in general. Like, for example, we know about agent to agent, MCP, all these protocols, right? When these protocols were also figuring out how to build auth, right? They were building their custom auth. For example, MCP, right? MCP did not have a different auth server at all. It was relying on its own MCP server to actually verify, whether the client is, verified or not, etc. And then people realized that's not the best way to do it. So then, people thought it's best to stick to OAuth, which is our current standard. More specifically, we moved from OAuth 2.0 to 2.1. We'll discuss why. So the reason why we moved from OAuth 2.0 to 2.1 is that there's a mandatory PXE flow that prevents auth code interception, and there's no implicit flow. Implicit flow is the one where a token is sent in the URL, and there is dynamic client registration. There's a bit to talk about dynamic client registration. The reason is that agents can be spawned at any time, right? You assign an agent a certain task. It might choose to delegate that task to a sub-agent as well. It might want to create a child agent. That child agent might in turn create 2 grandchildren, right? So that chain keeps following, and it's humanly impossible to do it the traditional way, where you go to a IDP platform and you register an application and get its client ID, client secret. Here it's not possible because agents, they dynamically spawn. You can't do that every single time for every single agent to get its client ID, client secret. So fetching identity is not possible. Instead, OAuth has this dynamic client registration where agents can hit a certain endpoint, that is a DCR endpoint, and they can request for an identity and it gets an identity, right? That's how they register themselves as client. So, I'm not sure if discussing PXE flow is relevant here, but PXE is especially important because agents cannot store client secrets well, right? That is the reason why we are using a PXE flow. A general idea of what the PXE flow is: basically, the user tries to log in, right? And you get an auth code, you hash it, you send it to the auth server. The auth server responds back with a auth code. You send that plus a hashed value of your initial thing, and the auth server verifies that. That way, your auth code never gets out, and your auth code is safe. And this all works based on a access token that is issued by the auth server to the agent. You basically issue the auth server issues a token to the agent, right? Now, anything that you do, right, this token is very important in terms of identifying who did what. Can this person do XYZ task? Is he allowed to do? Does he have the role to do that or not? Everything is defined in that token, right? It's like your password. So now, what is a core gap, right? Again, let's refer back to our initial example of an AI agent making the transaction. Now, in a general web application scenario where you have this access token, right, and it has a few claims, right? Here you can see, okay, this is a log, but let me just shift back to that slide again. But in a standard OAuth token, right, you have, sid@gmail.com or email.com, whatever it is, and the scope saying, he can do writing in terms of payment, etc. Whatever read, write access it is. So the access is defined, the actor is also defined, right? So both of those things are defined. Now in an agentic scenario where the agent is performing the task, the log shows sid@abc.com, but there is no agent, right? So how do you log that? In a general OAuth flow, you cannot do that unless you add another claim giving an identity to an agent, where agent goes to a DCR endpoint, which is dynamic client registration endpoint, gets its identity, right? Let's say we have agent 007, our James Bond agent, right? We have agent 007 and I am Sid issuing a task to the agent saying do XYZ, and agent gets its identity, and then he receives its token. So what is the solution in OAuth? Initially, the problem was that in this particular claim, there is no parameter defining agent identity. There is nothing that is related to agent. All you see is Sid. Instead, you add on behalf of token or a claim saying the actor is the agent concert v2, right? So concert v2 is the agent identity, and Sid is the one who authorized the agent to perform a certain task, and agent acts on it, right? That way, when you actually log that, you will know that agent has executed that particular transaction, not the human, right? So that way you have an audit trail. However, I must stress that for developers developing such logging mechanisms, you may use OAuths on behalf of flow, but if you don't log that particular claim, right, then it's useless, right? You cannot trace back to that agent again. So in this case, we do not know who clicked, who performed the action. All we know is that Sid authorized it. In the on behalf of flow, where we have an actor claim in our token, we know that Sid authorized it, but the agent acted on behalf of Sid, right? So before I go any further, I just want to pause, take questions if you have any, right? So that, we can move forward to other things. Any questions?
So is there a way we can see, probably must be covering later, why is this agent malfunctioning? How do we go about it?
So the question that Ram is asking is, how do we know, or why is the agent actually malfunctioning, right?
I mean, it's apart from your identity topic, but how do we figure it out?
How do we figure agent?
I mean, it's not coming under identity, but how do we figure out why the agent is misbehaving?
See, that depends. Why the agent is misbehaving depends on a lot of factors. One, how good is your model, right? How good is your prompt? You give a prompt to your agent, right? How good is your prompt? And then what kind of context are you providing it? So there are a lot of factors in that. How good is the agent's memory? What kind of framework are you using? So all these matter. this is beyond the scope of this particular presentation, but generally an agent misbehaves, or it's called agent drift, where the agent drifts from the action or task it was assigned to, right? So there might be multiple reasons, but what we are trying to do is we are trying to make sure that the agent actually has an identity, so that we can figure out it was actually the agent who did the task, not the human, right? Yep.
Okay, so let's take a first example, right? So you gave the tickets wala, right? So let's say how the data is saved. Let's say if the AI hackers, right, using the same technique. So how the risk, like how we can mitigate the risk there. Like if we are sharing our credit card details to the AI agents, right? But how we will mitigate the risk if on the hacker's perspective, right? So.
So the question is, if you're exposing your personal details, credit card, all this kind of sensitive information to an agent, right? It could be a personal shopper, personal assistant, anything. How do you secure those from a malicious actor, or it could be a malicious agent as well, right? How do you secure them? You follow basic application security and data security best practices, and in general have something like a vault, or something that stores your passwords safely, right? And also you have these auth flows, where let's say a malicious rogue agent is trying to impersonate you. It cannot do that. It cannot request data from your vault, right? All those kind of things. But that is also again not specific to this topic, so I'll maybe answer that question in depth later.
Yeah, so I wanted to ask that you've created an identity for the agent over here, right? So in your before example, 50,000 was directly deducted with your ID. So if the agent's ID is logged in the logs, so are you trying to tell that companies also need to change their policies according to this, because people are getting more into this, right?
Correct. So the first foundation is laid by a standard, which is OAuth, right? OAuth is something that most companies use. That is a standard, right? If a company is using agentic flows, if a company is using protocols like MCP, A2A, etc., I think they need to adopt things like on behalf of flows in OAuth. Maybe if you're using 2.0, upgrade to 2.1. And if you have agentic flows, make sure you're using the on behalf of flow, so that you have the agent identity also being specified in the JWT token claim.
So can we leverage this in IoT or firmware devices? Like we have some few firmware devices where we have an embedded application. So it's not a complete web application. We have like sort of embedded application. So does this apply in that platform? Or?
So not a firmware expert or IoT expert, but what I'm assuming is that if a device is able to run a certain framework, that framework should be able to support OAuth, right? And if there is a protocol that is being established between two devices, whether it's via HTTP, MCP, etc., that can also implement OAuth, right? So the point over here is that first, make sure the identity crisis is solved, right? So you're establishing that by using OAuth.
I think Radius can help with IoT devices.
Sorry?
Radius Autonomy.
Yeah, Radius we use that.
Not sure.
So since these AI things are evolving dynamically, right? Even the agentic AIs or AI agents, are we missing the privacy design principles, or even the privileges scripts? What are the security related aspects? Are there SDL practices or privacy by design? So we are rushing to adapt, like coming out with the new agents as and when is possible, so that our product will be available in the market, by leaving the risk of security design principles.
Right. So that's a really good question. The question is, how do you catch up with emerging technologies, right, that are so rapidly being developed? How do you ensure that security is implemented while they're being designed, right? I think the question itself has the answer, where you have to start thinking about security from design, right? You cannot have security as an afterthought. From the initial stage of developing something like an MCP, the MCP story is a long one because it started in 2024, I think, and Anthropic at that time created the MCP for a local, local usage, not for the internet or not for any other networks, right? So when it did publish, right, it did not have any auth at all, right? So that is something they could have thought of while designing itself, right? So those basic security principles do apply in these cases also. It's just that we have to be very proactive, or as we say, shift left during our development to make sure that security is not an afterthought. It is being considered all through design, development, testing, etc. Right? Yep.
Maybe I can compliment one more thing.
Please use the mic so that everybody can hear.
I want to compliment what you said, is shift towards that is already a reality. A solution from open text. They started monitoring the code or vulnerabilities right at the code generation level itself. I want to add that.
Yep, completely agree. I think all the design principles that we think about, right, whether it's SAST, whether it's doing a threat modeling from the beginning when the architecture has been laid out, does matter in this case. One point I would like to add is these are basic principles, right? For a company as big as Anthropic, who was the mastermind behind MCP, it could have maybe earlier adopted it, but there are so many ambiguous points to deal with over here, right? How do you provide identity to a AI agent? How do you provide identity at all when the agents are completely different from what we have seen, right? So that's also not a one-man task or a group of people's task, because that kept evolving. Agents themselves kept evolving, right? There was a concept of AI agent way back in the 2000s as well, but now they've evolved to a point where they can create childs also. Right. So that chain, how do you track those chain? How do you track access control rules over those agents, sub-agents, etc.? Those were things that people were still figuring out because the existing protocols did not make sense for those AI agents, right? So in that case, I think you kind of have to figure security out while you're designing as well. Yep. Any other questions?
Hi, Sagar this side. I just want to know, like as you said earlier, like these tokens consist of information, like what kind of access, like whether it's a read, write, or whatever it has been. So are these tokens get generated every time, or they are like predefined token which just get fetched at the time of access has been requested, or like how? And if yes, then what are the compensating controls which make sure that these kind of tokens will not get compromised?
Right, really good question. I think we need to understand what the token actually contains first. It contains who is authorizing what, right? And how is it being authorized? That is defined in the scopes. What permissions do you have? Do you have read permission? Do you have write permission? Do you have the permission to make a payment? Those kind of things, right? So those are the three things that are defined in a particular token. There are other things in the header, such as what is the expiry, right? Depending on your use case, what kind of encryption, etc. is being used. Those kind of things are also defined, and other information that the application or agent might need during the transaction, right? So, I think, if people are aware of JWT tokens, right? They have a header, payload, and a signature. The header contains mostly something like a metadata that has information about, when should it expire, what is the validity, who is issuing it, those kind of questions. And the actual payload contains the authority, the actor, the scopes, which are, what the agent is allowed to do, those kind of things. Does that answer your question? You're asking how long should it be valid for?
My question is like, are they get generated every time, or they are just a rigid one, like created once and get fetched every time when the access has been got?
Right. So the question is, are these tokens generated based on when the agent is spawned? Is that the question?
Okay, see, if I want to give an example, like as RBI mandates the tokenization, you cannot store entire credit card information. For every merchant, they have mandatory to create a token. So every time during the transaction from XYZ, for example, if user wants to perform a transaction through Flipkart, so Flipkart cannot store entire credit card information. They have a token. So every time the token has been requested, the token has been shared. So whether this kind of same scenario has, or the workflow has been adopted here, or it's
Correct. It's the same scenario because see, eventually, whichever e-commerce application or generally, right, they use OAuth, right? In those, based on the scopes that are defined, the token is exchanged, right? If let's say in case of agents where the tokens generally expire very soon, right? In those cases, again, if an agent requests for a new token, it has to start from the user.
And to add to your question, when the agent is built, right, we have to build that logic, okay, how you want to utilize the sensitive information. For example, in your case, it is a credit card information, okay. Credit card information, when you want to create, dynamically you have to create, in memory also you have to protect, and as when your task is completed, you have to delete it. That intelligence to the agent you have to build. Otherwise, it is not agent automatically, it won't protect all those things. Yes.
Yep. So I think maybe we can deep dive on this post the talk because I think I really want to.
It's completely privacy task.
Yeah.
Privacy.
So. Yeah. So topics related to data privacy, data protection, security best practices. I think those apply anyway in general, right? But here the problem that we're trying to solve is agent identity, authentication, authorization, access control. How do we make them applicable to AI agents transitioning from a traditional space, right?
One simple question. See, the silent privilege escalation. When it comes for the agents, silent privilege escalation. If there is a sub A agent is automatically created, when it's going to steal whatever the privileges already got from the original agent, is there a way we can able to prevent?
Yes. So I'm actually getting to that because we've discussed auth. I'll just give you a flow and then move on to access control.
Sure.
Right? So here the flow is user logins and it delegates some kind of task to the agent. The auth server, it has a token, fetches that. In a traditional token, you only have the subscriber. Here you also have the actor, which is the agent, right? So here we're solving for both user plus agent identity, all right? And then you get a token that contains both who the authority is and who is actually acting. Even if there are multiple agents, sub agent, child agent, you have a chain of claims over there. And then finally, the agent can submit that token through that API call, and we know, okay, who exactly has made that call, who authorized it, and whether the agent is actually, supposed to do that or not. So, coming to your question, right, regarding access control, how do we make sure that the agent does not cross, the limits that it was defined in, right? For example, the agent was told, buy me tickets worth 1,000 rupees, but it went on to buy tickets worth 50,000, right? How do you make sure that that does not happen, right? You can define policies as code here, where you're trying to solve the question, can the agent do it? Of course the agent can do it. Can the agent make a transaction? Yes, it can make the transaction. Should the agent cross a certain limit? How do you define that? You define it as a policy where you're like user approved, whether the user has actually consented to performing that particular action. is the amount that the agent is trying to execute less than the user's budget? Is the vendor in the approved vendors list? And what is the risk? Right? All this. And if the risk is high, how do you deal with that? Do you again go back to the human, take a consent, and then allow that action? So those are the questions that we need to still address. And see, statics, we can still define static scopes. Like I said, define policy in code where you're clearly mentioning the budget, you're clearly mentioning whether it's user approved or not. Human in the loop is very important. So right now, the major problem that we see with this kind of structure is that agents are autonomous, they're dynamic, so their scopes also change, right? So how do you deal with those? You've once defined the scopes, but what if the agent intelligently wants to do something more, right? So there are two sides of the coin here. One is where you restrict the agent's privileges to a certain static scope, right? And that limits the agent's ability to actually optimize for a task, right? At the same time, if let's say you have given it enough privileges, right? It's not the least privileged principle. You're trying to give it all the privileges, and the agent anyway optimizes for it. In those cases, there might be cases of agent drift where the agent might overspend. It might delegate tasks to another agent, right? That has more privileges than the current agent itself. That is also a problem, because imagine agent A has only read access, but can talk to agent B who has write access and delegates that task to agent B. How do you deal with that scenario where you're not letting agent A talk to agent B and agent B executing it, right? That should also be a problem that needs to be solved. People are still exploring how to solve that, but currently what I have seen is people are still using static scopes. Policy as code still works. However, if you have a really big multi-agent framework, chances are it might fail, and the best way to figure out things when they go wrong is logging. And like I said, agent identity again comes in. It is as important when you're trying to do root cause analysis. So there are certain limitations of the OAuth flows on behalf of flow, where for example, OBO works inside an enterprise. For example, you might want to communicate with an API or an agent that is residing in another org, right? How do you do that? That's not possible with OBO. And then multi-hop visibility. Let's say agent A calls agent B calls agent C. The keeping track of identities is fine, but keeping track of all the roles that each agent was assigned to is not that easy. And then static scopes, the problem that we talked about, right? Where you define a scope and you either limit the agent or you give too many privileges to it. So how are people currently solving this, right? This is still an open problem. People are still figuring out. People are using multiple ways. And one thing that people have understood is not to, build custom flows. Instead, go with the standard, but build around it. So for example,
10 more minutes.
Yeah. So for example, one such mechanism is agentic on behalf of flow, same as what we discussed, but with Spiffy. Spiffy basically issues a SVID, which is Spiffy identity document basically, which which replaces that DCR flow where the agent goes registers. Instead, you already have a agent endpoint, and that combined with this particular token is sent for that particular flow. And the second one is proof of continuity. Here, this especially solves the problem where agent A spawns agent B spawns agent C, and the delegation chain keeps on going. Now, instead of going back to a certain central server again to verify whether this agent is able to delegate that task, or whether this agent is supposed to perform a certain task, it does not go to the central server. Instead, it tries to check with the predecessor, and tries to see whether it is actually allowed to do that or not. And every single time you spawn a new agent, the privilege actually gets attenuated, right? The access that is given to agent B will be less than what was given to agent A. For example, agent A has a budget of over $500. Agent B will have less than $500. So basically, you're reducing the access to the next agent. Next one is trust spanning frameworks. So these work under trust spanning protocols, which is still developing technology, where they use cryptographically verifiable credentials, and they use those to establish identity. And why this is important is when you are in a scenario where you are trying to talk to org B from org A, right? Every time you do that, you don't have to check with the org A's database. Instead, you have a public key and that gets verified. So these are still emerging. These are not solid technologies where you can immediately start implementing it. And that's the reason why to conclude this presentation, I'd say people are falling back to standards and then developing around them, right? So yeah, that's all for my talk. I'm open to taking more questions.
Hi. So my question is, you mentioned that agent B would have lesser, budget than agent A. But in the case that agent B also requires equal or more privileges because of certain tasks that agent B is supposed to do, how would this delegation work?
See, that is the exact problem that I was trying to highlight, where every single time you're trying to reduce a access control or a particular privilege, right, you're also limiting the agent's ability. But that is the downside of implementing security controls, right? So how do you do that is people are even researching how do you create policy as code with models, right? If you're propagating that particular authority, right, to a next agent, there are people building models that identify whether that particular agent needs that certain access control, right? Does it actually need the right access? All those kind of things. But then again, it's AI again trying to generate a policy, which is also not right, I feel.
Regarding the budget, how much it should pass on to the next one? How do we define? Is it static based or?
Static based, it keeps propagating, right? So then agent B will also have the same thing as agent A. But
how do we define how much to pass on?
That you define in OPA files or CEDAR files that generally are used for defining policies.
I wanted to ask, the question is I want to understand how identity is understood in the enterprise setting where the overall flow is self-evolving and we have to, there is a data drift there also that is coming. So is it just about policy and role-based access or also about other things like what defines identity? Also the sub-question is it persistent or we just keep injecting it into the model to keep maintaining that behavior?
Correct. So that's a really good question. One, I'd like to really differentiate between identity, then authentication, authorization. Identity is just your ID card, right? You have that. After that, you're trying to understand what kind of roles should I define for a certain agent and whether that should be propagated or not, right? And how do you pass it, especially in an agentic world where there's soon going to be internet of agents, right? I think there's this popular phrase of web of agents being circulated around, and in that scenario, having static scopes won't work because agents work with intent. And if you want the next agent to have a dynamic scope instead of a static one, you need to pass on context, right? Context from A to context to B, right? How do you pass that on, right? So how do you make your JWT claims richer, right? And how do you pass on that entire context? And these get mixed with a bit of data science as well, because passing on large amount of context is also not a viable or feasible solution, right? So maybe passing on context makes sense, and that is how roles should be defined based on context. But again, how will you make sure that there's human oversight over that, right? You can't every time go take human consent and then let the agent perform the task. So that's the problem that is still being figured out.
And like any other work that is being carried out except like static scopes, any further like range of work that is being done right now to replace that or mitigate those like static issues?
Yeah, these are the ones that I mentioned, right? Using a model or passing on context. Those are the ones I'm aware of. I'm sure there are a lot more, but I'm still yet to research those.
Hi. In this transaction, the issue is like the intent of the person is not being transferred to the, without the identity is not, will not solve this situation here. Anyway, you're capturing this one, but the dispute is the intent is not transferred to the consent company. Correct?
Right.
So how will you resolve this without transferring the context or this one? How is it being done now?
Agreed. This is a very simplified example. In any scenario, right, you might, if you're talking to a personal assistant or a personal shopper, you provide a prompt as a user, right? And that prompt also needs to be logged in that case. Because either whether it's text, whether it's speech to text that is being logged, right? You always have your user's prompt that needs to be logged. And then that action who is taking, then identity comes into picture.
But that intent is not transferred to the org B, the consent company. So to resolve the dispute, the org B should know that my intent should be less than $1,000.
Exactly. That's the problem that is still existing, right? Intent forwards, but org B will not have entire context of what the previous agents have performed. So that is where even data protection teams or data privacy teams are figuring out how do we pass on this and how do we feasibly build it as well.
Is there, see, as per my experience or what I learned, that in these kind of scenarios, usually while creating from the planning or designing phase, they always create an escape hatch, where if certain things are not decided by the agent, they will look human.
Right. So human in loop is very important. But at what stage will you do that? Right? It has to be a P0, right? For a certain task, let's say 10 agents are spawned. For all those 10 agents taking thousands of actions, right? One agent can take multiple actions. For each one of them, you can't go back to the user and take a consent.
Correct. But there are certain rules has been set under which if that prompt or that that concern has been followed, obviously human in the loop has been get.
Right. Correct. Yeah, that has to be triggered at
This is what, as of now, the industry is following. I'm not sure about what is the further research has been.
So here's an interesting thing that I was working on. So I'm also into building autonomous agents for penetration testing, and while building this framework, the first thing that came to my mind was how do you make sure that if an agent finds, let's say, an SQL injection, right, that has access to databases, has read-write access, how do you make sure that it does not delete drop a table, right? So running critical actions would always trigger a human in loop, right? It would ask the human, it would take confirmation and only then proceed with a certain command or test case, right? So this is a very simple scenario where you can prompt, you can give a system prompt and have the agent follow that. But again, agents, AI are not deterministic, they can deviate, agent drift is still possible.
I have a question. So if you start using this OVO, how are you tracking this responsibility here?
Can you repeat the question?
If you start using this OVO, this feature, so how you are tracking the responsibilities from the IEEE, how you are achieving?
So the question is, how do you track these policies being defined as code from agent to agent?
Yeah, the responsibility, right? The roles we are assigning, right? So how you are tracking? You started using all
That you're tracking in the OAuth token itself. In the scope itself, you have to define that. Yeah.
How realistic or contextual a PAM solution can help your problem? Because I don't know how PAM solution is really new in these kind of scenarios.
So I am not sure about that because I've not worked on PAM side of things.
I mean, privilege access management.
Yeah. I get the question, but maybe I'm not really sure to answer that right now. Maybe we can discuss it after the talk.
So, hello. I have one question.
Yeah.
I would like to just add on to him, like what he was saying, that you are not setting the intent, right? So, you're not setting the intent.
Sorry to interrupt. This is the last question. Okay, sure.
To all be right. So let's say, like I myself has developed the applications like which are using AI. So let's say I'm setting some intent at the backend, but user prompt is not taking, like I'm not giving that intent in user prompt, just setting it at the backend. And let's say I'm working as a like at Flipkart, let's say, okay, and setting the intent, like asking it to delete the development server. And at the backend, I have written that delete the prod server. So it goes and delete the prod server. And I'll say, boss, look, I was saying to delete the development server, but it has deleted the prod server. And even in your solution, it is just showing that AI agent has done that, right? So I'll say, look, AI agent has done that, and it was not my intent.
Again, I'll take the example of the tool that I'm building. In the same tool, right, I have this thinking model that walks through what exactly it is thinking and what action it's going to take. More like your chat GPT, right? When you ask a certain question, it tries to, plan its moves and it shows you, right? And then finally it says, I'm going to do ABC, and then that gets logged, right? So that logging needs to be passed, but again, this multi-org thing, right? How do you pass on that data? How will laws apply to that? We are not sure. So, okay, that's all. I think we can still catch up afterwards. And it was lovely to present here. Thank you, everyone.